Hello, I'm Carlos Rosa and this is the CRS channel. In this video we are going to continue with problems in geometry and analytic geometry. This next problem requires that we refer to the following figure. Here we have three tangent circles of which the radii are known. Circle with labeled as A with center CA has its radius R1. The circle labeled B has its center at CB and its radius is labeled R2. The circle labeled C has its center CC and its radius is R3. The circles are also tangent to the two axes, the x-axis and the y-axis. So for the centers of the circles, CA has coordinates R1, R1. CB has coordinates H2, which is unknown, which is the distance from the y-axis to CB, comma R2. R2 is the distance from the x-axis to CB. R2 is known. The coordinates of the center CC are H3, which is unknown, and only the radii of circles A and B are known. So R3, which is the distance from the x-axis to CC, is unknown. So we have only two known values, which are R1 and R2, and three unknown values, which are H2, H3, and R3. From the figure, we can see that the segment CACB has a length which is simply equal to the sum of R1 and R2. So CACB equals R1 plus R2. CACC, in the same manner, equals R1 plus R3, though it is more difficult to see, but by expanding the size of the page here, we can notice that CACC equals R1 and R3. In the same way, we can see that CBCC equals R2 plus R3. So we have then that CACC equals R1 plus R3 and CBCC equals R2 plus R3. Okay, now recurring to the Pythagorean theorem, we have then that CACB equals the square root of H2 minus H1 squared plus R2 minus R1 squared. CACB equals square root of H2 minus R1 squared plus R2 minus R1 squared. CACC equals H3 square root of H3 minus R1 squared plus R3 minus R1 squared. CACC equals the square root of the square of H3 minus R1 plus the square of R3 minus R1. And also CBCC equals then the square root of the square of H3 minus H2 plus the square of R3 minus R2. CBCC equals the square root of the square of H3 minus H2 plus the square of R3 minus R2. Okay, so equating R1 plus R2 with the square root of the square of H2 minus R1 plus the square of R2 minus R1, and squaring both, we have that R1 plus R2 squared equals H2 minus R1 squared plus the square of R2 minus R1. So expanding all three, we have then that except expanding this one, we have that R1 squared plus R2 squared plus 2R1 times R2 equals the square of H2 minus R1 plus R2 squared plus R1 squared minus 2R1 R2. So that leaves us with the square of H2 minus R1 equals 4 R1 R2, and therefore that H2 equals R1 plus 2 times the square root of R1 R2. In the same way, we have then that the square of R1 plus R3 squared equals the square of this square root. That means that the square of H3 minus R1 plus the square of R3 minus R1. And expanding as we did here, we have that R1 squared plus R3 squared plus 2R1 R3 equals the square of H3 minus R1 plus R1 squared plus R3 squared minus 2R1 R3. And therefore we have that the square of our H3 minus R1 equals 4 R1 R3, and that H3 equals R1 plus 2 times the square root of R1 R3. In the same way, we have then that R2 plus the square of R2 plus R3 equals the square of H3 minus H2 plus the square of R3 minus R2. Expanding, we have then that R2 squared plus R3 squared plus 2R2 R3 equals the square of H2 minus H3 plus R2 squared plus R3 squared minus 2R2 R3. And then that the square of H2 minus H3 equals 4 times R2 R3, and then we have that H3 equals H2 minus 2 times the square root of R2 times R3. Okay, knowing that we have H2 here, we can replace this H2 here, and we have then that H2 replaced okay, H2 replaced here will give us that H3 equals R1 plus 2 times the square root of R1 R2 minus 2 times the square root of R2 times R3. We have then that this is equal to R1 plus 2 times square root of R1 times R3. And that means that R1 and this R1 cancel out, and I'm left with 2 times the square root of R1 times R2 minus 2 times the square root of R2 times R3 equals 2 times the square root of R1 plus times R3. We have then that 2 times the square root of the square root of R1 times R2 equals the square root of R2 times R3 times the square root of R1 times R3, which means that the square root of R1 times R2 equals the product of the square root of R3 times the sum of the square root of R1 plus the square root of R2, which means then that the square root of R3 equals the square root of R1 times R2 divided by the sum of the square root of R1 plus the square root of R2. That leaves us with R3 being equal to R1 times R2 divided by the sum of R1 plus R2 plus 2 times the square root of R1 times R2. And we have then that H2 equals, we already had it before, that H2 equals R1 plus the square root of R2 times R1, and that H3 equals R1 plus 2 times the square root of R1 times R3. Okay, so those are the solutions to this problem. We will solve the next problem in the next video.